Hello everyone, today I am excited to share with you our project titled the Intelligent Cloud-Based Odor Modeling System, an electronic nose platform for coffee fermentation monitoring. On this slide, you can see the main hardware components used in our coffee fermentation monitoring system. First, we have the coffee fermentation tank, where the fermentation process takes place. Connected to it is the SXT2 sextant gas sensing device, which captures the volatile compounds released during fermentation. Finally, all the sensor data is collected and processed by the data acquisition computer, which runs our analysis software. Let me explain the main purposes of our system. First, we aim to establish distinct odor profiles throughout the coffee fermentation process. Second, we work to build a clear relationship between the sensor responses from our gas sensing device and these odor profiles. Finally, we use these gas sensors to classify the quality of coffee beans based on their fermentation status. As you can see in the images below, the fermentation progresses from unfermented to moderately fermented, and finally to overfermented, each with distinct characteristics that our system can detect. The process is automated through a series of steps, from initiating the experiment, stabilizing the system, setting baselines, collecting gas samples, waiting for reaction stabilization, to desorbing gases and completing the experiment. You can see real-time status updates and control events such as valve and pump states. This automation ensures precise timing and consistency throughout the data collection process. During the collecting phase, we actively record the sensor responses to capture the odor profile. Afterward, the system enters the purge phase, where clean air is used to reset the sensors for the next measurement cycle. This process ensures accurate and consistent data for analysis. Here, I present the results of our coffee fermentation monitoring system. On the left, you can see the relative change rate of sensor resistance over different fermentation days. The data clearly shows an increasing trend in sensor response over time, which reflects the progression of fermentation. On the right, the fermentation trend charts compare sensor responses for coffee beans of different qualities. As you can see, beans of varying quality exhibit distinct fermentation response trends, which validates our system's ability to classify coffee bean quality based on odor profiles. Thank you all for listening to my presentation today. I hope you found the insights on our intelligent cloud-based odor modeling system and its application in coffee fermentation monitoring valuable.